Okay, this is lesson 4.6, Arithmetic Sequences. That word's right here if you need to know how to spell it. Okay, so a sequence is just a ordered list of numbers. And each number in a sequence is called a term. So they have a specific position in the sequence. And if we look at this, obviously, this is the first position, second, third, fourth, fifth, all the way to some position we don't know, so we use an N to represent that number. So in an arithmetic sequence, the difference between each term, when it's the same, that's how you know it's an arithmetic sequence. That's called your common difference. That's the easy part. So from 5 to 10, okay, they added 5. They added 5 more, 5 more. So our common difference here would be plus 5. I think the bell's going to ring in the video in just a minute or two. So I apologize for that now. So in extending an arithmetic sequence. So this says write the next 3 terms of this arithmetic sequence. So we have -7, -14, -21, and -28. So this is pretty easy because we just look at what's happening. From -7 to -14, we are taking away 7. So they show that you're adding a -7. That's the same thing. Just so you know, the common difference is -7. But you're just subtracting 7 each time. So you would continue that. So -28 minus 7 more is -35, minus 7 more is -42, minus 7 more is -49. So that way, you just continue it, and so our next 3 terms would be -35, -42, and -49. So I want you to go ahead and try numbers 1 and 2. On your own, you're just finding the next 3 terms in that sequence, and then we will go over them. Okay, on 1 and 2, we're just having to find the next 3 numbers in this sequence. So on 1, we're adding 12 each time. So we continue that. 24 plus 12 is 36. Or in this case, you're basically multiplying by 12. Times 1, times 2, times 3. 12 times 4 is 48. 12 times 5 is 60. That's the next 3 numbers in that one. On number 2, excuse me, sorry. From point 2 to point 6, we added point 4. And did it again right there. So each time we are adding point 4. So we continue that. 1.4 plus 0.4 is 1.8. Plus 0.4 more is 2.2. Then plus 0.4 more is 2.6. Okay, the next thing we're going to look at is graphing an arithmetic sequence. So since it's an arithmetic sequence, we know there's a common pattern, okay? And then it says, what do you notice? So all they give us are these 4 numbers. Well, to graph something, you have to have a point. So each one of these is a term, okay? So if you notice, we can make a table, and they say, okay, your terms are here. And this is going to be what position it's in. That's the other part of your point. So this 4 is in the first position. This 8 is in the second position, 12 is in the third, and 16 is in the fourth. So those now become our points. So this is your X, this is your Y. That's the point 1, 4, then 2, 8, 3, 12, and 4, 16. So then we go and graph them. And then it just says, what do you notice? So after you plot the points, if you notice, I'll try my best. I knew that was going to be wiggly. It makes a straight line. So they lie on a straight line. So then we look at another one. This one works backwards. On this one, they give us the graph. It says, does this graph represent an arithmetic sequence? And explain. Okay, so there's 2 ways you could do it. Well, yeah, we better do it their way. That's probably the best way. Okay, so from this, they went ahead and gave us the points. So we could write those points down. Position 1, it's the term 15. So we write that down, 2, 19, 3, 9, and 4, 6. And if you notice, we can look, we are subtracting 3 each time. So since they had a common difference of -3, it does represent an arithmetic sequence. So I want you to try numbers 4, 5, and 7. You don't have to do number 6. Try those 3, and then I'll go over it with you. On this next set of problems on 4 and 5, we're graphing. So they give me 3, 6, 9, 12. So those are your points. This is your first term, second term, third term, fourth term. So that's the point 1, 3, 2, 6, 3, 9, and 4, 12. So we go and graph that. So I have my 1, 2, 3, 4 on the bottom. Since it goes up to 12, I'm going to count by twos. So I have the point 1, 3, 2, 6, 3, 9, 4, 12. So it told us to graph it, and then it said, what do you notice? And on that one, if you graphed them correctly, there is a pattern each time. So it is a straight line. Okay? Then on 5, we have 4, 2, 0, negative 2. So that's the point 1, 4, 2, 2, 3, 0, and 4, negative 2. So on this one, we go negative. So I guess I should have done my graph a little differently. I'm going to count my ones on this. So I have the point 1, 4. I have the point 2, 2, 3, 0, 4, negative 2. And again, we notice it makes a straight line. Okay, on number 7, we were given a graph, and the question says, does the graph shown represent an arithmetic sequence? So if we look at this, they're kind of spaced out. Like these are close and then spaced out, spaced out. Also, if you notice, 1, 2, 3, 4, but then it goes 2, 4, 7, 11. From 2 to 4, that's plus 2. From 4 to 7 is plus 3. 7 to 11 is plus 4. It's increasing each time. So that is not a straight line. So to describe that, you would say just no. Okay, the next one, we have an equation for an arithmetic sequence. So you're going to need to write this equation down. We're going to be using this. It's like a formula, okay? So this is A sub n, that's how you say that, equals A sub 1 plus n minus 1 times d. Okay, that is the formula. Now what this means, A1, that's your first term. N minus 1, that's part of the equation, just like your x. This A sub n, that's like your y. D represents the difference, the common difference that's happening between your terms. So we'll look at a problem that uses that to kind of explain it a little bit. So it says, write an equation for the nth term of the arithmetic sequence. So here's our sequence. Then find A sub 50. Okay, so first thing we do, let's go ahead and find our common difference. From 14 to 11, that is plus a negative 3, or minus 3. 11, 10, 9, 8. Again, same thing. And 8 to 5, same thing. So since we're subtracting 3 every time, that is our D, negative 3. It's because we're plugging it into this equation. So we have A sub n equals, okay, so A1, that means your first term. The first term in that sequence is 14. So I replace the A1 with a 14, and I replace the D with negative 3. Now I solve this. Just like our y minus y1 equals m, if I can write it, times x minus x1. That's actually what this stems from. It's kind of the same thing, it's just we don't have y and x. Instead, we have A sub 1, n, and d. But it's actually set up the same way. So once we do that, we next have to distribute that negative 3. Negative 3 times n is negative 3n. Negative 3 times negative 1 is positive 3, so plus 3. And then they went ahead and combined the 14 plus 3 to get 17. So this would be your answer on that. A sub n equals negative 3n plus 17. We now have a function or a equation for our arithmetic sequence. So then we have to answer the other part. Find A sub 50, which means find the answer for the 50th term. That's actually pretty simple. All you do is we take, I'm going to have to erase some stuff. We take that equation that we just found. So our A sub n equals negative 3n plus 17. And we're just going to plug 50 in for n, which means the term. So I just replace that. That means negative 3 times n, so negative 3 times 50. When we do that, let's see, 50, 100, that's negative 150. Then plus 17 is negative 133. So the 50th term is negative 133. Okay, so it's not as complicated as it looks. You're going to start with this equation on all of these, so you need to get that memorized. A sub n equals a sub 1 plus n minus 1 times d. The only two things you replace are the d for the common difference and a1 for the first term. Okay, so I want y'all, let's see, go ahead and try all three of these at the bottom. We'll get some good practice writing these equations. So on 8, 9, and 10, you're going to write an equation for the nth term of the arithmetic sequence, then find a sub 25. So pause the video, try those, and I'll go over it. 8, 9, and 10, we are writing an arithmetic equation, and then it said to solve for a of 25. So we start with this equation or this formula. So I would always write that down. That'll help you start to memorize it. A to the n equals a to the 1 plus n minus 1 in parentheses times d. So if you remember, what we plug into this are a1 and d. a1 means your first term in the sequence. D is the difference between what's happening in each order of sequences. So we come over here. What's happening each time is we are adding 1. So that is our difference. Our first term is 4. So I come over here. 4 plus n minus 1, our difference is 1. 1 times anything doesn't change it. So I'm left with this. We can drop these. 4 minus 1 is 3. So a to the n is going to equal 3 plus n, or n plus 3 on that one. So then when we go back and it says find a of 25, I plug that in. Means n is going to be the 25th term. No, I plugged that in wrong right there, y'all. Sorry. Hold on, let me make sure I wrote this problem down right. Oh, I never wrote it. Okay. Hold on, I'm going to have to pause the video and restart it. Okay, y'all, so I'm sorry. I had to pause the video because I thought for some reason I had written the original problem down wrong because I didn't remember getting this answer. But I didn't. I was just having a brain fart. Okay, so to do a of 25 for the 25th term, now that we have our equation, we just plug it in. So we have 25 plus 3, which is 28. So on A, our answer is this and this. Okay, so now for number 9, I'll switch colors. We are adding 8, 16 to 24, still adding 8. We're adding 8 each time. So when I come over here to this original formula, I have, I'll just do it here. A to the n equals a of my first term, which is 8, plus n minus 1 times the difference we got each time was 8. So on this problem, I've got to distribute because it wasn't a 1. 8 times n is 8n, minus 8 times 1 is, or negative 1 is negative 8. So now 8 minus 8 cancels. So this one, a sub n equals 8n. That's our equation. So then to find the answer, we do a of 25, which means we do 8 times 25. That would be 200. Okay, and then last one, 10. From 1 to 0 is plus 1, or excuse me, minus 1, or plus a negative 1. So then each time we are subtracting 1 on that one. So I'll switch colors again. I have my original function, so a sub n equals the first term, which is 1, plus n minus 1 times the difference each time, which was times negative 1. So I have to distribute that negative in there. N times negative 1 is negative n, because I almost said plus, so minus n. Negative 1 times negative 1 is positive 1. So I have 1 plus 1 on here. So you could leave it 2 minus n or negative n plus 2. So my equation on this one is a sub n equals 2 minus n. That's our equation for our arithmetic sequence. And then a of 25 is going to be 2 minus 25, which is negative 23. Okay, so there are your answers on 8. Oh, I'll move so you can see them a little better for 8, 9, and 10.